Hello guys, welcome back to our session. This one is a May June 2023 session, paper 1-1. So we're still continuing with this chemistry multiple choice revision series, right? So remember guys to stay sharp and to manage your time, and also how best to use the method of elimination to find the most appropriate answer when answering multiple choice questions. So let us dive into the next set of questions. So we are starting with question number 11. Are we together, guys? So the question says concentrated aqueous sodium chloride is electrolyzed using innate electrodes. So which row shows what happens in the electrolysis and why it happens? So the question requires us to have a deeper understanding of electrochemistry. Are we together, guys? So uh, you need to go and check on my playlist. I've posted a video on electrochemistry for junior chemistry and also electrochemistry for advanced level. Are we together, guys? So I need you guys to pay special attention as I'm going to illustrate this electrolysis, because it's one of the fundamentals reaction or electrochemical reaction in the electrochemistry. So it is also called electrolysis of brine. Are we together? Brine concentrated aqueous sodium chloride. So you need to pay special attention. I need you to have a deep understanding of electrolysis so that whether it is examined in structured or in multiple choice, you can still ace your exams. Are we together, guys? So I don't want you to cram answers. I don't want you to memorize answers. I want you to have a deeper understanding of the fundamental principles. Are we together? So first, I want you to define those terms: electrolysis, uh, electrodes, and also electrolytes. Are we together? So for the reaction of concentrated aqueous sodium chloride, it is our electrolyte. So I want to define those terms for you because these are the questions of structured exam. Are we together? So electrolysis, it is defined as the chemical breaking down of a compound by passing an electric current through it when it is either in molten or aqueous state. Are we together? So the key terms here are the chemical breaking down of a compound by passing an electric current. So electric current, and also uh, either in molten or or aqueous aqueous state. Are we together? So those are the chief or the key terms in the definition of electrolysis. Are we together? So I want also to define the term electrolyte for you. As I've alluded to, that brine is the electrolyte in the electrolysis of concentrated sodium chloride. So an electrolyte, it is defined as a compound which, when in solution or when in molten state, can allow current to pass through it, and at the same time it decomposes. For example, we've got many ionic compounds like sodium chloride, copper 2 sulfate, lead 2 bromide, and etc. So you need to familiarize with electrolysis of those compounds I've mentioned, right? So I want you to understand that electrolysis doesn't take place in solid particles, right? It only takes place in aqueous or molten state. So you need also to take note of that one. And also for electrodes, electrodes are defined as the points through which current either enters or leaves an electrolyte. So for this electrolysis, we have got innate electrodes. So we've got graphite and also platinum. Are we together, guys? So these are the two electrodes that we have for the electrolysis of brine. So I want someone to define or to give a relationship between graphite and diamond in the comment section. And I promise something for that one person, for that one lucky person, to first give the definition of graphite, the relationship between graphite and diamond, describing it with a single word, right? So let us go into the question. So let me highlight the ions involved. ions involved in the electrolysis of brine. Ions present. So we've got anions. Anions, we've got chloride and hydroxide, and then for cations we've got sodium and the proton, the hydrogen ion. Are we together? So at the cathode, hydrogen is being discharged, and by this equation, the equation is H plus electron to give hydrogen gas. So hydrogen gas is produced. So we have got bubbles of gas which can be tested. So you need to know how to test for hydrogen, how to test for carbon dioxide, and also how to test for oxygen. Are we together? So, and also at the anode reaction, chlorine is being discharged. So chloride ion are being oxidized, and then hydrogen ion are being reduced, right? So oxidation, the loss of electron, the decrease in the oxidation state, and the gaining of hydrogen. And then reduction, it is the gaining of electrons, the gaining of hydrogen, and the loss of oxygen. So chlorine is being oxidized as it loses this electron to form the chlorine gas. So it's chloride ion to give chlorine 2 plus an electron. Are we together, guys? So here we need to balance with the 2, and then here with the 2. So this is the balanced equation for the anode. So we need to know what determines which substance or which chemical element to be discharged at any of the electrodes, right? So we've got three features which governs the discharge of ions, right? So first we've got preferential discharge of ions, and then second we've got the type of electrodes used, and also thirdly we've got the concentration. So those who have ions which are which are in abundance, right? They are discharged firstly, and also those those ions which are more reactive, they are less likely to be discharged. And also for the type of electrodes, I will show you as we are going to do a question for the electrolysis of copper 2 sulfate. Are we together? So with this data, I assure you that you can ask any question of electrolysis of brine. So let us go back to our question. So the question says, which row? So the question says, which row shows what happens in this electrolysis and explain why it happens. So oxygen is discharged at the anode. So we go to the anode. This becomes false. We have got chlorine. So this becomes false. So we don't care about the explanation why, because it is false. During electrolysis, the pH of the electrolyte increases, right? The electrolysis, why we go to the explanation, the electrolysis in the aqueous solution involve reduction of hydrogen ions. So this one becomes true because hydrogen is being released, hydrogen gas. So this becomes correct. pH is the measure of hydrogen ion concentration in a solution. So hydrogen decreases. Why? Because hydrogen ions are being reduced to hydrogen gas. So the lesser the number of hydrogen ions, the more the pH. So this sounds correct. Are we together? So we go to option C. Sodium is produced at the cathode. At the cathode, there is hydrogen. So this becomes false. So option D says the products stay the same if aqueous sodium chloride is replaced by molten sodium chloride. So this is false. Why? Because we are using different reagents, different electrolytes. So the product definitely differs. So in molten sodium chloride, we are going to have sodium at the cathode and then chlorine at the anode. So this one is false. Why? Because here at the cathode we are having hydrogen. So our answer becomes B. So I need you to have a deeper understanding, not just screaming of answers. So we are now moving on to question number 2, which says which statements about the energy changes during a chemical reaction are correct. So activation energy is the maximum energy that the colliding particles must have in order to react. This is false. Why? Activation energy, it is the minimum minimum, not maximum. This becomes false. So we go there where there is 1, we cancel that option. So we are left with C as our correct answer. So we can we'll read other options to confirm the answer, right? During an endothermic reaction, thermal energy is taken in from the surroundings, leading to a decrease in temperature of the surrounding. This is correct. The making of a chemical bond is an exothermic reaction. True. So you need to be aware of the energy change diagrams, right? Because this one it might be there in your examination, right? So I need space to draw the proper energy diagrams for you. So you need to pay attention on this data I'm going to show. So we've got exothermic. This one is for exothermic. So here in the vertical axis we've got energy, and then here in the horizontal energy we've got the progression of the reaction. Are we together? Reaction progression, the progress of a reaction. So let me draw it for you. I know my drawings are not that good, but you need to be patient with me, guys. So here, like this, and then so this one is our activation. This one is our activation energy, and then here is the energy change. So this is the loss of energy. So it's a negative, right? And then here we've got the reactants, and then here we've got the product. So as you can see from this diagram, the energy level of the reactants are at the higher energy level than the product, meaning to say some of the energy is lost to the environment. Are we together? So you need to know this diagram. So I'm going to show you the diagram of this one was for the exothermic reaction. So I'm going to show you the one for the endothermic one. Are we together? So for endothermic, let me write endothermic, endothermic. So here is the diagram. So you've got energy, and then here reaction progression. So reaction RP. So I will start by the reactants. So the reactants are at the lower peak than the product. So here P for the products, and then R for the reactants, and then here is our activation energy. Are we together? So here is our activation energy, and then here is the change in energy, which is positive change in energy. Why? Because energy is being absorbed to form new bonds. Are we together? So this is the energy profile. You need to know this energy profile diagrams by heart, because they are going to be examined in your structured questions. So for multiple choice questions, you only need to know how to label this diagram, where the product is, where the reactant is, and also to label the activation energy, right? And I assure you that we are going to ace your exams if you stick to the rules I give to you, right? So we now move on to the next question, number 13, which says two gases react inside a sealed vessel. So the question says which change in condition would increase the rate of the reaction. So you need to know the Boltzmann distribution curve, which shows the kinetic theory of gases in order for them to react, right? So I will show you that. We have a video on that one explaining to you what is needed for gases to react effectively, right? So the first statement says increasing the pressure inside the vessel. This is correct. Why? Increasing pressure increases the number of effective collisions, thereby increasing the rate of effective reaction. So for a reaction to occur, particles must collide um, in the correct orientation with sufficient energy to form bonds, right? So we've got what we call transition state in a reaction. So transition state, it is a peak of the graph, which for the energy diagram I've shown you before. So the peak of that graph is what we call the transition state, right, where there is forming and breaking of bonds. So for that to increase, we need to increase the number of effective collisions, right? Are we together? So now go on to option number 2, increasing temperature inside the vessel. So increased temperature increases the kinetic energy of the particles, thereby increasing effective energetic collision, thereby increasing the rate of a reaction. So this is true. So by option number 3 says increasing the volume. So according to the Boyle's law, volume and pressure, they are inversely proportional to each other. So when we increase volume, we thereby decrease so the statement number 3 says increasing volume of a vessel. So volume and pressure, they are connected by what we call the Boyle's law. So the Boyle's law says that pressure is inversely proportional to volume. So P is inversely proportional to V. So when we increase the volume, we therefore decrease pressure, thereby decreasing the number of effective collisions. So option three contradicts with the first option, right? So this becomes false. So our correct answer is therefore statement 1 and statement 2. This is option number B. We now move on to number 14. So number 14 says catalyst change the rate of a reaction. So which statements correctly describe the effect of adding a catalyst to a reaction? So I need to draw the Postman distribution curve for you, but I will do that for a video. I will post a video for it to explain the effect of temperature, the effect of volume, the effect of catalyst in a chemical reaction. So this is what we call reaction kinetics. So we now read our statement. So the first statement says all reactants particles have more energy and move faster. So this is incorrect. Why? It doesn't apply to the application of a catalyst. So a catalyst, we want to define a catalyst. A catalyst works by providing an alternate route with lower activation energy. So contradictory to many publications, right, which says that catalyst reduces activation energy. Catalyst doesn't reduces activation energy directly, but it provides an alternate route with lower activation energy. So for the sake of exam and passing, we will say that a catalyst lowers activation energy, which is statement number 2. So we will mark statement number 2 as correct. This one is false, and then statement number 2 correct. So we go wherever there is statement 1 becomes false, this one becomes false, this one becomes false. And then we've got the number 3 statement, which says more reactant particles collide with more energy, with enough energy to react. So this is true. And our final answer becomes option number C. So we now move on to number 15. So those are industrial chemistry. So the question says the equation for a reaction in the conduct process is shown below. So this is the conduct process, the manufacturing of sulfuric acid. So the conditions are 450 degrees Celsius, 2 atmospheres of pressure in a catalyst. So I want someone to name the catalyst in the comment section. So the catalyst for Kodak's process is vanadium pentoxide or vanadium trioxide. So I want someone to name the catalyst for the Haber process, right? The manufacturing of ammonia. So the question says, what will be the effect when the temperature is reduced to 250 and a catalyst is removed? So this is chemical equilibrium. So in chemical equilibria, for structured question, when you are describing chemical equilibria, you mustn't left out this statement according to Lee Chachalias. That's the chief term in equilibria, in chemical equilibria. So you need to state the Lee Chachalias principle and always remember to state according to Lee Chachalias and explain your answer. So your starting point must be according to Lee Chachalias principle. So you need to take note on that one. So let us go to the question. We are required to explain the effect when temperature is being reduced to 250 and a catalyst is removed. So this one is an exothermic reaction as shown by this energy change. Are we together, guys? So lowering temperature for an exothermic reaction shifts the reaction to the right side, thereby increasing sulfur trioxide percentage. Are we together? So sulfur trioxide increases, so this cancels, this becomes false, this becomes false, and then we are left with option C and D. So we are now looking on this statement, catalyst is being removed. So when catalyst is being removed, the reaction becomes slow, but this doesn't change anything in the reaction mixture or in the equilibrium position. So the rate of the forward reaction decreases. True. So this is false. The rate decreases both for the reaction and both for the backward. So our correct answer becomes D. Are we together? So we now move on to question number 16. So question number 16 says universal indicator contains several dyes, and the reversible reaction of one dye, indole hydroxide, is shown. So we've got this equation, this reversible reaction. So we've got these statements: a few drops of universal indicator solution are added to 50 cubic centimeters of water, and also a few drops of dilute hydrochloric acid are added to the solution. So which row describes what happens when the acid is added? So as I've alluded to before, that hydrochloric acid, HCl, dissociates to form the proton H plus the chloride ion. So there's increase in the number of H plus. So according to Lee Chatelier's principle, when the concentration of the protons increases, we are going to favor the forward reaction, thereby producing an intense white color, right? Increasing the color Y, increasing its intensity, and also there is increase in concentration of water, thereby decreasing the concentration of hydrogen ions. So you need to understand equilibrium and to apply the Lee Chatelier's principle. Are we together, guys? So so the question says, which row describes what happens when the acid is added? So when the acid is added, we are going to favor the forward reaction, thereby pH will decrease. So we rule out option C and option D. And then by which color, the color of solution shifts towards color Y. So color X becomes false. So the option becomes B. So we are now moving on to number 17 says the combustion of methane is a redox reaction shown by this equation. So is in my previous videos I've shown the fastest and the most accurate way to balance combustion of hydrocarbons. So you need to check my playlist of organic chemistry. So the question says, which statement about this reaction is correct? So we need to know the definition of redox reaction for our structured paper. So redox reaction, it is a reaction which there is both oxidation and reduction. So the answers are only carbon is oxidized. Only, you need to take note of this term. Only means strictly carbon is being oxidized. So here carbon gains oxygen from carbon dioxide through carbon is being oxidized, and then hydrogen gains also oxygen to form water. So this statement becomes false. Why? because not only carbon is being oxidized, but also hydrogen is being oxidized. And also carbon, the oxidation state of carbon changes from -4 in methane to +4. I can show you how to calculate the oxidation state. So the oxidation state of carbon is X, the unknown, and then for hydrogen it is plus 4, since we've got 4 atoms, right, of hydrogen. So this X plus 4 is equal to 0. So X is equal to negative 4. So we can do the same for carbon dioxide. So there's a change from -4 to +4. So carbon is being oxidized, but it is not the only being oxidized, and also hydrogen is being oxidized. So this becomes false. Only carbon is reduced. No, carbon is not reduced. It is oxidized. So this becomes false. Only oxygen is oxidized. False. Oxygen is not oxidized. So only oxygen is being reduced. True. Oxygen gains hydrogen, which is reduction. And then oxygen reduces, the oxidation state of oxygen reduces from 0 to -2 here, right? So our correct answer is equal to D. Are we together? So we now move on to number 18. So number 18 says, which method of preparation of magnesium sulfate is an example of a redox reaction? So you need to define a redox reaction. We have defined redox reaction in the previous question. So we now go to our option. So option A says magnesium plus sulfuric acid to form magnesium sulfate plus hydrogen gas, and then magnesium oxide plus sulfuric acid to form magnesium sulfate plus water. This is neutralization reaction. This one is displacement reaction. Magnesium hydroxide plus sulfuric acid to form magnesium sulfate plus water. This is also neutralization reaction. Magnesium carbonate plus sulfuric acid to give magnesium sulfate plus water plus carbon dioxide. So you need to know the reaction of a metal with an acid, a metal oxide with an acid, and a hydroxide with an acid, so that you can be able to write the correct equation for stoichiometric calculations. So we want to pick out the reaction where there is both a reduction and oxidation. So here the oxidation state of magnesium is 0, and then here the oxidation state of magnesium is +2, right? So here there is oxidation, increase in oxidation number, right, and the loss of electrons. And then here the oxidation state of hydrogen is +1, and then here the oxidation state of hydrogen is 0. So here there is reduction, decrease in oxidation number. So this one becomes a redox reaction, right? So mostly displacement reactions are redox reaction, and other acid and base reactions, they are not involved in oxidation states. So this becomes false, this becomes false, this becomes false. So here there is maintenance of the electroneutrality, right? Of charge neutrality, right? And then here maintenance of a charge neutrality. So the reaction is called a neutralization reaction, meaning to say it is neither acid nor basic, but it is neutral. The reaction chamber remains a neutral. Are we together? So this one becomes false, and then the correct answer is A. Are we together? So we now move on to number 19. So question 19 says a sample of hydrochloric acid and nitric acid are tested using the universal indicator paper. So the sample of hydrochloric acid is a pH of 4, and the sample of nitric acid is a pH of 2. Which statements are correct? Hydrochloric acid is a weak acid, and nitric acid is a strong acid. This is false. This is false. Hydrochloric acid is not a weak acid. This is false. This becomes false. For weak acid, we've got organic acid like ethanoic acid. So our strong acid, we've got nitric acid, we've got sulfuric acid, we've got hydrochloric acid, and we've got phosphoric acid. So I want someone to write the chemical formula of phosphoric acid in the comment section. So option B says nitric acid is a lower formula mass than hydrochloric acid. This doesn't answer the part of pH. Mass and pH are not related, so this becomes false. And then the nitric acid is more concentrated than the hydrochloric acid, so this becomes true. The reason why the pH of nitric acid is lower than that of hydrochloric acid might be the concentration. Since pH is the measure of concentration of hydrogen ions in a solution, so for nitric acid to have a lower pH, it simply means it has got more concentration of hydrogen ions than those in hydrochloric acid. So this becomes true. And then for option D says the hydrochloric acid is dissociated more than nitric acid. So this one is false. Why? If hydrochloric acid dissociates more, it will provide more protons, thereby giving more a lower pH, right? So this becomes false. Why? Because the pH of hydrochloric acid is 4, and that of nitric acid is equal to 2. So our answer becomes C. So we now move on to question number 20, which says which two substances react to form salt and water only. So this is the neutralization reaction. So it takes place between an acid and a base. So we just need to pick where there is an acid and a base, right? So aqueous sodium carbonate and dilute sulfuric acid, this is false. Why? Because the reaction produces salt, water, and carbon dioxide. So there is effervescence of carbon dioxide, which is tested using lime water, right? So you need to know the confirmatory test for carbon dioxide. So this becomes false. And then option B says aqueous sodium chloride and aqueous silver nitrate. So this is what we call a precipitation reaction, where there is exchange of the salt anions, right? So you have got the nitrate and the chloride. So the sodium picks up the nitrate, and then the silver will picks up the chloride ion. So the confirmatory test for this reaction is the formation of the white precipitate of silver chloride. So you need to know these tests for silver chloride, and then the test for the bromide and the iodide ion. So the iodide ion gives a yellow precipitate with the lead 2 metal. So lead Pb2 plus the iodide ion gives a yellow precipitate. So I need someone to tell us the color of the bromide precipitate, right? So this one becomes false. And then the option C says aqueous sodium hydroxide and dilute ethanoic acid, right? So this one is true. A neutralization reaction is a reaction between an acid and a base. So this one becomes true. And then option G says zinc and dilute hydrochloric acid. So this one is a displacement reaction to give hydrogen gas and salt. So the confirmatory test for this reaction is the production of a bubbles of gas, which is tested using a burning splint, which produces a popping sound. So you need to know the test of oxygen, the test of hydrogen, and that one of carbon dioxide. These are enough for your examination. So this makes our answer C. So we are done for this session. So stay tuned, as I'm going to send a link for the next session